Okay, Scoresby. Light. 3-1, ladies and gentlemen, 3-1. Okay, so today we are going to write a quadratic. Okay, here's our lovely quadratic. What kind of graphs have we had for our quadratics before? We've had graphs that look like this, right? Correct? We've had a graph that looks like this, have we? Yep. Something of that, right? We've had a graph that looks like this, correct? Now we've also had the max kind of graphs as well. I just showed mins, but at the same time you get what I'm going at there, right? That's the mins. We've also had those where it crosses twice, crosses none, and crosses once, right? So what we're doing today, guys, just to give you a heads up of what we're doing, we're going to be solving by factoring. Okay, so you already know how to factor. That's awesome. But what I'm going to kind of show you why we kind of solve by factoring is we're going to look for our x-intercepts sometimes. Not right now, today that's not our goal, but I kind of want to give you an idea of what the point of what we're doing today is. Because later we will be asking these questions. Okay, what was a y-intercept? Anybody remember? Where it crosses the y-axis. What do we know special about the y-intercept? What is 0? X is 0, right? So remember, a y-intercept, x is 0. And we had some point, in this case it is 24. Okay? Does that make sense to everybody? Well, when we're looking for today would be kind of, if we had an equation like this in a quadratic, we would be looking for our x-intercepts. Okay? Our x-intercepts. What do you guys think an x-intercept means then? When y is 0. Great. How many y-intercepts can you guys have in a normal quadratic? 1, right? In a y-intercept, we're only going to cross this axis with a quadratic only once. How many x-intercepts could we have? Well, here's my 3 different styles of graphs. How many x-intercepts do I have on this one? 2, right? It crosses here and here, correct? Does that make sense? How many times does it cross here? 0. It doesn't have an x-intercept. Kylie, I think you sit right behind... I just lost your name. I just got to figure it out. Hold on. Jessica. And then how many times does this time cross? 1. So you could have 2, none, or 1 x-intercepts. Does that make sense? When we have a quadratic. And that's what we're going to be looking for today. But we don't ever have a y equals today. We're just basically solving. And the reason why we solve sometimes is we need to look for these x-intercepts when y is 0. So I'm going to plug in 0 for y. Now once again, one thing I want to talk to you guys about, on the previous test, we had a lot of kids do well in factoring. And I had some kids try to figure out the pattern, but they try to find a trick. And it worked on some things. It usually worked on things that had a leading coefficient of 1. Okay? And they went ahead and factored those. But at the same time, they didn't know what to do when the leading coefficient wasn't 1. Does that make sense? So, once again, the way I show you guys, it works every time and not just in simple special cases. Does that make sense what I'm trying to go for? The way I teach is trying to teach you something the way it works every time, and that doesn't have a special case. Does that make sense what I'm going for? Okay, so what's our first process when we go ahead and try to factor? Rainbow it, right? Okay, so we take the front number, which in this case is 1, and we multiply it to the back. Once again, if you struggled in factoring, you really want to pay attention because this is what this whole lesson is about today. Okay, 1 times 24, what is that? 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8. Go ahead, I'm sorry. It's not going to work. Let me tell you why. I understand where you got it because you would subtract to get that one, right? Because 12 minus 2 would give me 10. But notice because this is a positive, remember these guys have to have the same sign, don't they? Because how do we get to a positive number? A positive times a positive or a negative times a negative, correct? Well, if this was a negative and a negative or a positive and a positive, would I get to 10? I'd get to 14, wouldn't I? Does that make sense? I can see where you're going there, and I appreciate it, but we've got to keep going, right? And then notice, 4 and 6, good. Okay, but are we done? How about 5? And then notice, see how 6 wraps around. Once again, when it wraps around, that shows you every factor. Because I had some students on their test say, Mr. Roberts, I can't find the factors. Why? It's because it was a big number and you decided to stop. Right? I think it was like 210, and people are like, oh, I got to 8 and something. Whatever it was. I don't know. I know 8 doesn't really fit. But you get what I'm trying to say by that. I hope you do. Right? Meaning, got to get it to wrap around so you have every factor, because the time that you don't go all the way around, that's the time you could see those ones you're missing is the factor you need. Does that make sense once again? Okay, so with this being a plus up here, once again I choose to add where 4 and 6 is the pair that I'm going to use, correct? Is everybody there with me? Okay, so we come over here, once again we're not changing the value of the expression, we're just rewriting it. Does it matter the order I put these two in? Doesn't whatsoever, does it? Okay? Doesn't matter the order as long as it equals 10. Only thing that will happen in the end is my binomials will be switched because of the commutative property. Right? Okay. Emmy, what do these guys have in common? They do have an x. If I pull out that x, Emmy, what's left over? Awesome. Thank you, Emmy. Okay. Jessica, what do these guys have in common? Thanks, Kylie. We'll go with Kylie right now. I'm coming back to you. I'll get you on the next one, Fairdale. Kylie, they have a 4, right? What's left over? Awesome. Thank you, Kylie. And once again, this still equals 0 over here. I forget it sometimes. I apologize. Okay. Now, what do they have in common? They don't have x plus 4 in common. They have the x plus 6 in common. This is what they have in common, correct? And what's left over, Haley? All right. Okay. So notice, we're to there. 0 equals x plus 6 and 0, excuse me, does that say x plus 6 times, x plus 6 plus, minus, divide, what does it say? It says times, right? X plus 4. So when you're timesing two numbers, by the way, you guys understand that this binomial is considered a number. If I plug in a value, that will be a specific number. If I put in a value here, this would be a specific number, right? For example, if x equals 3. 3 plus 6 is 9. 3 plus 4 is 7. That would be 9 times 7. You get what I'm trying to say, hopefully. So, if you're multiplying two numbers, how does something get to be 0? Something has to be 0, doesn't it? Does that mean my x value is 0? No, this value, right here, this binomial, needs to be 0, or this guy needs to be 0, or sometimes they're both going to be 0 at the same time. Does that make sense what I'm trying to go for? So what value of x makes that guy 0? Negative 6. Does everybody see that? If you can't, just set him equal to 0 and solve. We'd subtract the 6 over, wouldn't we? Okay. Now, what value makes this guy 0? Well, if you can't see it, once again, set it equal and solve. Not always. So that's once again something you're noticing. And yes, sometimes it is just the opposite value. But not always. So I don't want you to think of it that way, okay? Alright, those considered my x-intercept. So if I was going to graph, which today we're not, I'm just trying to get you a picture of idea of what these x-intercepts are, or why we're solving factored form, or why factoring would be helpful in solving for these x-intercepts. So we're right here, 1, 2, 3, 4, 1, 2, 6. Okay. So those are 2 points on a parabola, correct? A quadratic equation. With that being said, what do we know about parabolas? It does look like a U, right? It's symmetrical, correct? Isn't parabola symmetrical? And what do we know about things that have the same y value? Remember, how did I figure out if something had the same y value? Anybody remember? Keegan? I think he said it. The middle would be the vertex, because if they're symmetrical, that means their midpoint would be the halfway point, or where the vertex would be, correct? Does that make sense? Because they're equidistant away from the vertex. So, not 5, but negative 5 would be the x value of my vertex. This is where we started at, by the way. Y equals x squared plus 10x plus 24. Okay, and as Michael just said, okay, my vertex would be at negative 5 comma what? How do I get that what? We plug it in. It can't be 24, that'd be my y-intercept. Is that what you said? Because once again, here's negative 6, here's negative 4. What's the halfway point? Or the midpoint? Wouldn't that be negative 5? Because once again, if they're the same y value, that means they're equidistant away from the vertex, right? Remember that, how we graph? We would graph the vertex, we'd find the y-intercept and count how many away it is, and then use the symmetry to go to the other side. So now, we're using symmetry and cutting it in half to find the vertex. Because now we just have to find the y exactly. Okay, so when I plug that in, that's negative 5 squared plus 10 times negative 5 plus 24. So that's 25 minus 50 plus 24. Comes out to negative 5. So right here, and notice all the way up at 24. There's my graph, basically, isn't it? Now, once again, we're not doing this. But I want to show you that what we're doing today, if we were doing it and solving, what we do when we factor and find the x-intercept is where it crosses the x-axis. Okay, does that make sense to everybody? Okay, so here is something that we are looking for. Another name is, we call it zeros. Okay, when we actually have an equation y equals blah blah blah, we actually can have an x-intercept. Does this start off with a y equals? Yes or no? It doesn't. So are we going to have x-intercepts if it doesn't have a y value? These are called zeros, or you could say the roots of an equation. Okay? Zeros and roots of an equation. Where's your pajamas? I thought your sister would make sure that you had your pajamas on today. And you're like, yo. You're alright. You're good. Okay. So the lucky thing on this one, what's already nice about this one? Do we have to do any factoring? It's already there for us, huh? So Jake, this is the reasoning. Here's 2 examples why you just can't do the opposite. Kind of like what you said, is do the opposite. So 5 would have made this guy 0. It would, because if I put a 5 in there, what's 2 times 5? 10, and 10 minus 5 does not make me 0, right? So that's why I wanted to say, be careful on what you said there. Does that make sense, Jake? But what did I do, ladies and gentlemen, on my last problem? Right down here. Oops. I had these binomials, and what did I do to them? I set them equal to 0, didn't I? Because I want to know, when does this binomial equal 0, right? So I set it equal to 0, because when I set it equal to 0 and I solve, that tells me what value makes it 0, correct? Okay? So, I'm going to do the same thing. I'm going to set the binomials equal to 0. Okay? So, I have 2x minus 5 equals 0, and 4x minus 3 equals 0. Hayden, you mind help me solve the top one, please? How do I get rid of that minus 5? You would add it over, right? Okay? So I have 2x equals 5. Everybody good there? So what do I do now? Is this x? That's why x isn't equal 5, because x isn't by itself. This is equal to 2x, isn't it? Divide by 2, as Haley says, and so this comes out to be 5 halves. And 5 halves is the value that makes it 0. Okay? Once again, do we like 2.5? Those are for devils. You don't like the devil. Hopefully you will. You can if you want, but that's a little weird. Okay, so go ahead and find the other one really quick. You guys think the other rule is try the other one? Okay, so we go ahead and add the 3, wouldn't we? And divide by 4. So the answers that make this equation 0 are these two yahoos right here. You're in the hood. That's pretty clever on my part. I like laughing at my own jokes. Okay, what about this yahoo? Do we have a value, a C value in this case, like an ABC value? It is 0, so we can't really do our our factor using the rainbow method, can we? Because why we can't do that? Because what's 2 times 0? 0. What's the factors of 0? Anyway, it just isn't a good time. Okay? Huh? What? Well, I could still basically work with it, but it's okay. I'll show you what to do. So, can we look at this and say to ourselves, Self, what do these two yahoos have in common? A 2 and what else? Don't they have an x as well? Okay. So they have a 2 and an x in common. Okay. So, with that being said, what value makes this equation 0? What value or values, I should say. So what did you say right here? -4. This one's pretty easy to see that it's -4, correct? Parker, you doing good back there? I'm tired today too. Like driving this morning, I'm usually like screaming at kids, going whoop like that, waking them up, and it's kind of fun. It puts a little adventure in there, They swerve a little bit. Nope, this is not in vertex form. Because what's the value that makes this guy 0? Does that make sense? Well, I do the same thing for this fella too. I just set him equal to 0. How do I get x by itself? I would add it, divide it, right? Because that's timesing, correct? So x equals 0 divided by 2, and what answer would that be? 0. And that makes sense, because notice what's 0 squared? 0. 0 times anything. 0 times anything. 0 plus 0, 0, right? Comes out to be 0. Are we good with that? So if you ever just have, this is called a monomial, right? A single term, monomial, monopoly 1. Right? So our answers to this equation would be x equals -4 and 0. That's the answers. Answers. We'll do that tomorrow. No, well, we got to get to that process. Because there's some, we've seen, I think sometimes, how many guys did the remediation for the factoring, and then I think there's number 4 on there. And that guy didn't factor. There was no factors to factor it. So sometimes it doesn't factor, but there's still 0. And I'm going to show you how to do that. I believe 2 more days. It's the quadratic formula. Sir? No, we're not trying to find our y-intercept because there's no y to begin with. The only reason why I started that way, Jake, is just so you got a perspective of why we're doing these things. Because in the end, we're going to have equations, and I might want you to find the x-intercepts. And that's basically what we'd be doing if this was an equation instead of an expression. Well, this is an equation, I should say, because it has an equal sign with an equal value. But you get what I'm saying. Basically, but I'm going to do some harder ones. Yes. Hey, oh, hey, hey. I like to be me?
Yeah, but
Why would I want to be anyone else? Touche on that, huh? I heard somebody FaceTimed me yesterday or whatever that's called. Snappy chat. That's a little awkward, wasn't it? Yeah. My nephew, I was watching my TV series, and he sent it to her. Maybe I was looking at my notes. Was I? I was just intent. What's wrong with this guy, guys? Doesn't equal 0, and we want it to equal 0. So what do you guys think we're going to do? I would add the 12x. Does it matter what side I get them on? It won't matter. So I personally am going to get the 12x over this side. Tyson, you all right today? Football's over with. You should be getting some more sleep and relaxation. No? I'm sorry, brother. All right. What are we going to do? Caleb, what are we going to do? We are going to factor. That's true. We are going to do that. We are going to do that. That's okay. Help him out there, Taylor. We're going to factor. And what do we do on our first step of factoring? We do our rainbow part, right? Whee! Skittles pop out. Just taste the rainbow, right? Thanks. Oh, will you go take that down to the top section? Okie dokie smokies. Emily, can you do my factor tree, please? Oh, look at you. Oh, you're so cool. You have it. Say it. You had it. You just didn't want to do it. Say it. You had it. You had it. Just trust yourself. And 5 can't go, but this being a plus again, what do we do? What do we do? What do we do? We add the little buggers. And that's 6 and 6, right? Okie dokie. Here we go. 4x squared plus 6, x plus 6, x plus 9. Once again, I'm not changing the value. I'm just rewriting. That's the whole goal. Don't change the value. Rewrite it. So, Tessa! Tessa! How are you, Tessa? Tessa? What do these yahoos that I just underlined have in common? They do have an X. Do they have anything else? Okay. Thanks, Sam. Give her some time there. You're not getting away because I'm going to help you. You're getting the next one then. You got some help. And if I pull out a 2x, that is a 2x plus 3. Tessa? What do these yahoos have in common? Does 9 have a 6 in it? Oh my heck, people ever think. That's what they have in common. Thank you. I'm glad you had so many subconscious people up here. Okay. So we pull out the 3, and I'm left with a 2x plus 3. Oh, it's so quickly. Thank you, Taylor. So they once again have these yahoos in common, don't they? So I pull out the 2x plus 3, and I pull out the 2x plus 3. So how many solutions is this guy going to have? 1, right? This is a guy that only has 1 solution. Because it's the exact same thing, isn't it? Everybody good with that? Bailey! Oh, we'll go for both of you. I guess he's such a gentleman. He volunteered for you because I was looking at you. Okay, Bailey, you ready? Okay. So how do I value makes this a guy 0? What do I need to do with that? Bailey, you might want to be a lady and help him out. You got to set equal to 0, right? Good. And because they're the same, I might as well just do the 1, right? So what do we do? What do we do? What do we do? Let's see what this color looks like. Wait, minus the 3, right? Oh, is it 3? That color sucks. We're not going him. We'll go with orange. Is it 3 halves? Negative 3 halves, I'll take. Not too shabby, right? Hugo, be a good boy. All right, Hugo. You soccer playing man. Here we go. Here we go. Okay. What's the difference between this? They're in binomials right now, but they're quadratics, right? So what could I do first? Probably what I want to do is factor. They do have something in common over here. How about that? So what do these guys have in common? Okay. So now I'm here. Does anybody know what these were called or what they saw as the pattern of these people on the test? I know some people got found them. Alex, what are these called? Oh, well, it's you poor little boy. You ready? You know what these factored into really nicely? Because I didn't teach you this way. Some teachers did show because this has a special name. These are called the difference of squares. X squared minus 9. Difference means subtraction. Isn't x squared something squared? And isn't 16 and 9 both something squared? Right? So these are called difference of squares. And notice what happens when we go ahead and factor these. Okay? What's in the middle here even though it's not there? Not a 1. Not a, well, the negative is there. Isn't that x squared? How many x's do we have? 0 x. I changed the value. What's 0 times x? 0, right? So I didn't change that. Just think about it. So 0 times x. So you want to know what equals the middle number, don't you? Same idea. Does that make sense? Okay, I'm going to show you guys this cool trick right on this one. It's not, well, I don't want the trick, but you can see it. Okay, so we go 1 times negative 9. What's that? Negative 9, Mr. Everett. Emmy, what's the factor tree of negative 9? Uno and nino. Can 2 go? How about 3? 3 and 3. Thank you, Emmy. With this being a minus, do I add or subtract? I subtract, and which pair is going to get me to be 0? The 3 and the 3. So, by the way, I'm just ignoring him right now. I'm still keeping him there, but I'm just ignoring him. Then we group the front two. What does the front two have in common? I'm coming back to Tessa, because everybody kept helping her. Wait until you don't get help, Tessa. Got ashamed? Tessa, what do those guys have in common? And what's left over if I pull out that X? Awesome, thank you, Tessa. Right. This 3 squared. Hasn't he always been outside? Oh my goodness, it's so hard. Kaisa, what do these guys have in common? Thank you. What's left over if I pull out the 3 out of him? X, what kind of 3? Minus 3. Thank you, Kaisa. Alright. Where did I lose your X? You okay? Alright, so now I pull out the X minus 3. So I have this 3 out here that was factored out. I pull out the X minus 3 and I'm left with X plus 3. Where did I lose you? Don't worry. So this 3 out here, see how he's consistently been outside. Don't worry about it. So notice I went 1 times negative 9. I rewrote it. What do these guys have in common? Right here. What's left over? X minus 3. What do these guys have in common? We haven't even touched him yet. Okay, can you guys see what happened here? What's the square root of x squared? X. What's the square root of 9? These are called the difference of squares. Difference of squares go into what we call these guys. See how they're the exact same thing except for a plus and a minus, which are called conjugates. Okay? Conjugates are just the exact same expression except the middle number changes. Okay? So, isn't this the same pattern? So what can I do? I just take the square root of this guy, which is x. Square root of this guy. And then I do x plus 4. Those guys are called difference of squares. Okay. Those are called conjugates. Because what's the square root of 16? So I could factor the same way I just did. Would you like me to do that? Do I find it? This would be x squared minus 4x plus 4x plus minus 16. Group. What do those guys have in common? Notice I pull out be x minus 4. What's left? X plus 4. Same thing. Okay, so this is we got this one and one other, and then we're done, guys. So what value makes this guy 0? Are you okay with that, Hanson? You okay? What value makes this guy 0? 4. Sometimes when you have the positive and the negative, they go plus or minus 4. Just to let you know. Okay? If you ever see that. What is this guy? Negative 3 and 3, so I actually have plus or minus 3 and plus or minus 4. He's just out there. Nope. Because look at this. This is kind of like, what value makes this 0? Here's just like 3 times 0 times blah, blah, blah. It doesn't matter. It's just the number being 1. Does that make sense to you? Nope. You can divide him over. What's 0 divided by 3?
Does that say x equals x?
Isn't that what an equal sign is? It's 2 lines?
No, it's like,
Doesn't really matter. Just for you. Just for you.
like, yeah, x
So,
x
so this is
minus 3.
plus or minus 4. What value makes him 0? 3. And plus or minus.
No, no, we just did x.
I just did a comma. Doesn't make a difference. Okay, last one. This one's not too hard, guys, so don't get stressed out.
Triangle.
I am looking for Hayden. Hi, Maddie. I have the triangle here, and it says this area is 2. So the area of the triangle is 2 units. Okay? So they're wondering what value of x would give me an area of 2 units. Okay? So can anybody tell me first off, how do we find the area of a triangle? Do you remember? Length times width, okay? I call it base and height, but it's the same thing. And we cut him in half, right? Does anybody know why we cut him in half?
No, it's half and half.
It's half of a rectangle, isn't it? Right? Some cool things you just never think about. Okay, so area equals a half times base times height. So here we go. What's our area? 2. What's our base? X plus 3, right? What's our height? I just did the height times base. It really doesn't matter, does it? Because the commutative property. Ooh, jingles. Hey, I really don't want to factor through with that 1/2, so how could I get rid of that half to get him to the other side? I minus him? Okay, he's already timesing. I would times because I don't like to divide by fractions. Well, instead of dividing by fractions, what can we do? Multiply by its reciprocal. Good. So I'm going to times 2 over 1 to both sides. Notice I get 4 equals, those guys reduce out, so they're no longer here. Bye-bye. Because I wanted to. And I'm going to go ahead and multiply through to get x squared plus 3x. Now it's something that we just barely did, isn't it? Correct? I'm with you, Jake. What do you got for me? Why would I want to? When I was... You could divide by fractions, but in the end, when we divide by fractions, we still multiply by the reciprocals unless you're using a calculator, which I want you to think first, right? So isn't the same thing... okay, so let me ask you this. Isn't 4 divided by 2? What's that answer? What is 4 times a half? Notice in division by 2, they use timing by its reciprocal. It's the same thing. Okay? And the reason being is if you think about this, Jake, okay? If you really think about this, remember, he has a power of 1, right? If I jump him upstairs, now that's 4 times 2 to the negative 1, isn't it? Or I could say 4 times 1/2. Because remember, jump the line, change the sign. What's anything raised to the negative 1? Remember, he jumps the line, changes the sign. Okay? When instead of dividing fractions, we multiply by its reciprocal. Okay? Okay. So what do we want here? Once again, Bailey, we want a... Man, we have a lot of Baileys. I know I have 2, but let me give him a shot. Give him a shot, Taylor.
He's too small.
Paige, I haven't heard your beautiful voice today. Have I? What do we do, Paigey? Add what? Well, we subtract 4. And then what? Now we're going to do what? Because I want everything on one side. I want it equal to 0. Does that make sense, Paige? So he was on this side, so I subtracted him over here. Which it doesn't matter. It's still equal to 0, right? I can flip flop. You with me, Paige? Okay, so what are we going to do? How are we going to factor it? 1 times negative 4, which is? And what's the factors of negative 4, Paige? 1 and 4. 2 and 2. All right. Which pair is going to be the one we are going to be using? 1 and 4. Okay, the key question now is who gets the plus, who gets the minus? The 1 gets the what? The 1 gets the minus. Why? Because I got to get back to 3x, don't I? And if I did it vice versa, that would be negative 3x, which isn't the same, right? Okay? That's a horrible 4. But you guys know me and my horribleness. That's okay. Nadie Underwood, I don't think I've called on you today. What do they have in common, Nadie Underwood? So what's left over, Nadie Underwood? Ooh, that's weird. You had it the other way. You're okay. You had it vice versa. Just look right here for me. What do these guys have? They have the x, so if I pull an x from x squared. You guys are so mean. Let people think. Well, then save that. Alright, thanks, Nico. Michael, what do these guys have in common? What's left over? An x. Not a 4. I pulled a 4 out. There you go. So I factor out the x minus 1, and Nate, you had it vice versa, but you still have these same binomials, don't you? It's just because you did the commutative property, didn't you? Okay. Kylie, what value makes those guys 0? Are we done? 4 does not make them 0. Negative 4 does. Does that make sense? Oh, I thought you said 4. I apologize. I'm sorry, Kylie. What value makes this guy 0? Awesome. Okay. 1 and negative 4 makes these guys 0. That's my answer. Woohoo! No! Anybody tell me why? One of those is my answer. Once again, what's the context of this problem? It's a triangle. Can x be negative 4? Does it make sense to have a side be negative? Is it okay for a side to be 1? We're okay with that, aren't we? 1 is our answer. Because, once again, the side of x equals negative 4 doesn't make sense in the context of our problem, right? Okay, look at this idea. I'll explain that a little bit. So sometimes we get into story problems with quadratics as a person jumping off the cliff. It's kind of goes like this. They jump up, get to their highest point, which is the vertex, and then come down, right? Maybe. Does that make sense what I'm trying to say? The x-intercept's where they hit the water. Well, if I use symmetry, even though this is the height and where time is 0, because what we're basically asking is how long it takes it to hit the water, right? So we have negative time. And notice, wouldn't that value over there where he hits the water on that side be a negative time? So his answer doesn't make sense. See how sometimes we got to find our answers with the context of our problem? Okay? Does that make sense? Ladies and gentlemen, we have a heck of a long time today. Okay? Which is awesome. So therefore...